Hey friends, Mr. Warden here, back in the workshop. It is a beautiful evening here in the neighborhood. I'd like to show you something. Still working on the coral table. Don't fret, there's a long video coming about this project. But in the meantime, as many of you guys know, I'm currently restoring a 1991 Chevy G20 van that I'm going to turn into a little house. And one of the things I've been doing is going through the lights and fixing those. The vast majority of the lights, because it's from 1991, are this style of light. This is a drawing of an incandescent light bulb. Okay. Now, the way that these worked is that electricity would come in through one end of this wire inside the bulb and then go out. And as that electricity went through the bulb, trying to get a good view of it, as that electricity went through the bulb, it heated up this wire, this thin wire, this filament. And it got so hot that it glowed. And that's what caused the light to come out of an incandescent light bulb, heat. But ultimately we discovered, much to our chagrin, that was very stressful for the wire, and sometimes it would cause it to break, and then the light bulb would burn out. So instead, more recently, we've moved on to LED lights, right? LED stands for light emitting diode. This is an LED bulb. Just trying to focus on my face, but maybe focus. You can kind of see it in there. Okay, I've drawn a close-up. Okay, here's a close-up version of that. Now, as you can see, this has a very similar structure. Electrons come in and electrons go out. But let me talk about how LEDs work. LEDs are a much more stable form of light. And in fact, I believe that once I put this light in one of the lights on the car, I believe that it will basically last forever. But how do LEDs work? LEDs are composed of sort of the same glass outer shell that an incandescent light bulb is, but it's composed of two parts that are made out of special material that acts as a semiconductor. Semiconductors can be lots of different kinds of elements, and it's not really worth getting into right now, but it is a special kind of material. And the reason it's special is because it can do this. Inside the LED, there are two halves delineated by this line. These two halves are composed of semiconductor material, but they're composed of two different flavors of semiconductor. One is called P and one is called N. One of them has lots of extra electrons hanging out. One of them, the other one, has holes where electrons might go. Okay, and what happens is that through this gap, this very tiny gap right here, electrons jump over. And so electrons come in. Some kind of werewolf outside. Electrons come in, and these electrons get pushed out and go over here. Meanwhile, this piece of material has lots of extra space for electrons, so it gathers lots of electrons, and then electrons keep coming in, and they keep pushing new electrons, and eventually those electrons get pushed out. And when those electrons get pushed out, something happens. Light comes out. Why? One of the things that happens when electrons move around is energy gets released. One of the main reasons that we're able to see color is because light from the sun, or energy from the sun, or energy from the lights in the room come down and strike the material that the objects around us are made out of. And the material reflects that light at us. And as the energy comes in and back out, this produces orange light. This produces orange flavored energy. much the same way. As electrons move in and out of this system, energy is released. That energy is a very bright white light. How do electrons come into this system? Well, primarily we talked about in the very first episode, we talked about batteries, sort of. Batteries are typically some kind of chemical process that there's a reaction happening inside the battery, and it's producing extra electrons, and the electrons have to have somewhere to go. And so they go through whichever wire is connected to that electron producing terminal on the battery. Okay. Inside this battery, there's a chemical reaction happening, and there's lots of electrons ready to escape from this terminal over here. From this piece of metal, there's lots of electrons ready to go. And so when I turn around, and I don't know if this is going to work exactly like I think, but I hope it does, because I need to strip these wires. All these electrons are going to get shoved through this wire, and they're going to start shoving electrons through the LED. And as the electrons move through the LED, it's going to produce light. Let me see if I can get this to function in the way that I think it's going to work. I don't know if this battery is actually even live. All right. This is an 18-volt drill battery. Okay. Don't know if it's going to be very clear to see because we're not using a good camera, but it has a plus and a minus side, just like a regular battery does. Just like a car battery does, right? These LEDs are meant to go inside of a, well, these are not necessarily meant to go into a car, but I think I bought these specifically because they're meant to go inside cars. Okay? Now a car battery is 12 volts, and so we need something that's at least 12 volts to kind of get this action to happen. Okay, this is an 18-volt battery. Now, if I connect the positive and negative of this socket to this battery, it should turn on because there's electrons in here that are getting ready to come out, right? And when the electrons go into this, they're going to push electrons through the system, and that movement of electrons is going to cause energy, and that energy is going to take the form of white light. Oh, man. Isn't that neat? Live the curious life, folks.